All right, day 2 of AVID focused note-taking. So I have my hardback science textbook opened up to where I was working. I have my piece of paper with my notes. I have my pencil, my red pen, and my blue pen. Make sure you have all of those materials. You can pause if you need to. Yesterday we took notes on these pages in the vocabulary, and that's what we ended up with. So today we're going to flip it over and work on this side. And you notice that we still have the skinny little column on the left. We still have a second column right there. And we can still see the crease down the middle for taking notes. Here I am on page 10. And we're going to start with the sun. Okay, I skip this little skinny column because that's where the big blue title goes. And I come to the second column. Capital T-H-E, the sun, capital S-U-N. Okay, put my red pen down, get my pencil, and read. The sun is a huge sphere of hot glowing gas called plasma. At a mean distance of nearly 150 million kilometers, 93 million miles, it is the closest star to Earth. When they say mean distance, they mean average, so it's usually about that distance. Of the billions of stars in the universe, the sun is average in most ways. It is a medium-sized yellow star that is about 4.6 billion years old. The sun is so large that more than 1 million Earths could fit inside it. Okay, so what is super important about all of that? Well, sphere of hot glowing gas, because that's where the energy is coming from we were talking about. So, over here, sphere, S-P-H-E-R-E, hot, H-O-T, glowing, G-L-O-W-I-N-G, gas, G-A-S, arrow, squeeze it in there, energy, E-N-E-R-G-Y. So that's how we're getting all that energy. I don't know if the size is going to really be that important, because all this is mostly about the energy and the day and night cycle. But this point about the sun being average kind of fits into what we talked about yesterday about the Goldilocks zone, the Earth being in just the right spot. So average in most ways. We're going to put that here. Average, A-V-E-R-A-G-E. And then equals, because it's average, size, S-I-Z-E, comma, age, A-G-E, comma, distance, D-I-S-T-A-N-C-E, like distance from the Earth. So it's just kind of average, and that helps us have liquid water on Earth, which helps us have life. Okay, next paragraph. The sun's mass makes up about 99.8% of all the mass in the solar system. Wow! So 99.8% of everything in our sun and our planets and our asteroids is actually just the sun itself. Its gravitational pull is strong enough to keep Earth and all the other objects in the solar system in orbit around it. Aha! So, it's huge, and that means it has enough gravity for us to orbit. Okay. So let's do this. Sun, capital S-U-N apostrophe S, sun's mass, M-A-S-S, squiggle, because it's about, 99.8%. So it's almost the entire solar system. 99.8% of solar, S-O-L-A-R. I don't have enough room, so I'm just going to come underneath it. System, S-Y-S-T-E-M. Sun's mass, about 99.8% of solar system. Now let's talk about the gravity. Strong, S-T-R-O-N-G. Gravitational, G-R-A-V-I-T-A-T-I-O-N, gravitation, A-L, strong gravitational pull, P-U-L-L, arrow, orbit, O-R-B-I-T. So the strong gravitational pull of the sun causes all the planets and asteroids and everything else in our solar system to orbit. Okay, next paragraph. As you can see in the table, that's this over here, the sun is extremely hot. At the sun's core, hydrogen is converted into helium through a process called nuclear fusion. So nuclear fusion, that's basically the same process as a nuclear bomb. This process releases a huge amount of energy that the sun radiates into space in all directions. A tiny fraction of that energy reaches Earth, heating its atmosphere, land, and oceans. Okay, so let's look down here. It said it was extremely hot, surface temperature, 5,500 degrees Celsius. So remember, whatever the Celsius number is, the Fahrenheit number is a lot higher than that. So it is more than 5,000 degrees Celsius. That could like vaporize metal, not just melt it into a liquid, but vaporize it and make it almost disappear. Okay, so let's say sun, extremely hot. Sun, capital S-U-N, extremely, E-X-T-R-E-M-E, extreme, L-Y, extremely, hot, H-O-T. And then what did they say? They said it was nuclear fusion. Some of its energy reaches Earth, okay? Sun, extremely hot. Come down here, and I'm going to indent a little bit so we know that these two go together. Some, S-O-M-E, energy, E-N-E-R-G-Y, arrow, Earth, capital E-A-R-T-H. So the sun is extremely hot, and some of that energy reaches the Earth. See how we only have 1, 2, 3, 4, 5. We only have 6 words here that capture everything that was in that paragraph that we read. Okay, next. The sun is the ultimate source of energy for Earth. It is essential for life on Earth and drives ocean currents, winds, the water cycle, and weather. Wow. Go ultimate source of energy. That means it is a very important source of energy. So, ultimate, U-L-T-I-M-A-T-E, source, S-O-U-R-C-E, of, O-F, energy, E-N-E-R-G-Y. And do you notice how they keep telling us over and over and over again how many times the sun has energy? It gives its energy to the Earth. That causes processes on the Earth and drives life on the Earth. Just like we talked about the curve of forgetting. The more times we repeat it, the more we're going to remember it. So we're repeating this so many times that now we're going to remember that the sun is an ultimate source of energy for the Earth. Okay, Earth's living things use the energy of sunlight through the process of photosynthesis. Green plants and algae use this process to produce food. In turn, the plants and algae provide food for other living things, including humans. So in one paragraph, they're basically telling us that all that sun's energy helps plants grow. And then all the plants and algae growing feed a lot of the animals, especially animals that eat all the plants. And then predators eat those animals. So they're already leading us into food chain and food web. Okay, let's see. Something about photosynthesis, plants, and food, right? So let's say energy, E-N-E-R-G-Y, arrow, photosynthesis, P-H-O-T-O-S-Y-N-T-H, photosynth, E-S-I-S, photosynthesis. Synthesis is to make something or put something together. Photo means light. So the plants are literally putting things together, like their leaves and their stems, using photo, the light. So energy goes into photosynthesis. Arrow, plants, P-L-A-N-T-S. So the sun's energy is used in photosynthesis, which is the process that plants use to create food. So let's draw another little arrow from plants, and let's say food, F-O-O-D. And then that really means food for all the animals, herbivores that eat the plants, but also carnivores that eat the animals that are eating the plants. All right, I see a new heading, so I need my red pen. And I come down here, and I'm going to kind of skip a line right about there. Day and night, capital D-A-Y, and A-N-D, night, capital N-I-G-H-T, day and night. All right, let's read. Seen from Earth, the sun appears to move across the sky every day. It rises in the east, climbs to its highest point at midday, then lowers to the west until it sets. This apparent motion is due to Earth rotating like a spinning top about its axis. Earth rotates from west to east. So what they're saying is it's not actually the sun rising and falling, it's the Earth spinning. And so if you're standing, let's say you're standing right here in Florida, as it spins, the Earth spins that way, and you go from the dark part of the side to the light part of the side as you move. So if we're on the tip of the pencil, the sun is way over here to the left. The Earth is rotating so that we're coming across and it's nighttime and it's becoming early morning, and then the sun rises and it's morning time, and then by midday we have lunch, and then at night it starts to get dark again and we go back around to the other side. Okay, so let's talk about the day-night cycle, and let's talk about the Earth rotating on its axis. Okay, day, D-A-Y, /night, N-I-G-H-T, cycle, C-Y-C-L-E, day-night cycle. Indent a little bit, Earth, capital E-A-R-T-H, rotates, R-O-T-A-T-E-S, on, O-N, axis, A-X-I-S. So the day-night cycle happens because the Earth rotates on its axis. Took that whole paragraph and we smushed it down into 7 words. Okay, next paragraph. Earth's axis is an imaginary straight line that passes through the geographic north and south poles. So it's not actually straight up and down. It is, where's the picture? It is tilted a little bit like that. Each full rotation or complete turn about its axis takes 1 day. Okay, we already have that on the other side of the notes because that's a vocabulary word. As Earth rotates, the half facing the sun has daytime, while the other half has night. This gives rise to the endless cycle of night and day. Okay, so the only thing new here is about the north and the south poles in the axis. Okay, so axis, A-X-I-S, arrow, north, capital N-O-R-T-H, / capital S-O-U-T-H for south, poles, P-O-L-E-S. So the axis is an imaginary line that goes through the north and south poles. Okay, next paragraph. To help you understand, try the simple activity. First, select an object, such as a clock or lampshade, to represent the sun. Think of yourself as Earth. Stand so that you can just see the model sun out of the left corner of your eye, then slowly rotate in a counterclockwise circle. Okay, let's keep going because both of those paragraphs are connected. As you move, the model sun comes into full view, then is visible only in the far right corner of your eye, and later is out of sight completely. It remained in place while you, the model Earth, rotated. All right, so let's actually do that. Okay, let's pretend that that is the sun. And it says to put it on the left, so there we go. And that would be like morning or sunrise. As the day goes along, the sun comes into view and it gets warmer and brighter and hotter. And by midday, it is right in the middle. Now, in the wintertime, that's usually around noon, but in the summer, that's actually around like 1 or 2 o'clock. It's a little bit different because of the tilt, and we'll learn about that. As time goes on, the day continues to pass, evening and dinner time, and then it starts to get dark later at night, and eventually sunset, just like that. And then it would be dark. And it would be nighttime, and it would be time to go to bed. And the next morning, you'd wake up, and here comes the sun again. Okay, so that's what they're talking about in that paragraph. So I think it's kind of hard to describe that in just a few note words, but we can say something about that the Earth is rotating. It's not the sun actually rising and falling. So the Earth rotates on its axis, right? And we're going to say simulates, S-I-M-U-L-A-T-E-S, sunrise, S-U-N-R-I-S-E, / sunset, S-U-N-S-E-T. So simulates means it's not really happening that way. It just makes you think it's that way. The sun isn't rising or setting. It's just that the Earth rotating simulates a sunrise and a sunset. Okay, let's check other things. The picture. The sun continuously generates both light and heat. Let's go back to our notes. We talked a lot about heat. Photo, we said light, but let's actually put the word light somewhere. Sun, extremely hot, and line, the number 3 line, that's an and symbol. Sun, extremely hot and bright, B-R-I-G-H-T. And then energy, arrow, photosynthesis, we're going to do parentheses, light, L-I-G-H-T. So that we know light is part of the energy that's helping plants grow to produce food for everyone and everything. Okay, what's another picture? Here we go. Earth's rotation changes how the shadow falls on a sundial. What time does the sundial show? Well, these are Roman numerals. That little slash is a 1, 2, 3, 4, 5, and there's a 6, and it's kind of on the dot in between. So for that place, it's 5:30, basically. And that basically means like 5:30 p.m. I don't think there's anything we're going to add there on our notes. Cause and effect, what keeps Earth in orbit around the sun? I think we know that. Let's go look. Sun's mass, strong gravitational pull, orbit. So we would be able to answer that question. What keeps Earth in orbit around the sun? The sun's mass, being so huge, gives it a strong gravitational pull, period. That's what allows planets like Earth to orbit around it. So that would answer that question. Oh, one more picture. At any moment, it is day on half of Earth's surface and night on the other. Okay. Right here where it says day-night cycle, we're going to put half/half in parentheses. So we know the day-night cycle is kind of like a half and half thing. Half the Earth is in day, half the Earth is in night because of the way it's rotating and spinning. All right, that is it for today. Also notice that our page is not full. We still have room for the next day. Good job, persevere, and roar, Wildcats!